Hello everyone, I say Nawaz. I welcome back you to my YouTube channel Petroleum Universe. From now I'm just going to discuss about reservoir engineering textbook topics, which whose author is Mr. Tarek Ahmed. Sorry, Doctorate Tarek Ahmed, and that will be presented by me, obviously. Okay, so let us quickly see about the author of the textbook. That he is nothing but PhD in petroleum engineering from Oklahoma University, and he is an author of another book which is nothing but hydrocarbon phase behavior, which was published in 1989. Okay, so in this textbook he has 15 chapters, right, and each chapter linked with each other, and for preparing each chapter he has separate references. Okay, so among these 15 chapters, today I am going to discuss one topic of chapter 4th, which is nothing but fundamentals of rock properties. Okay, so in this among from this fundamental of rock properties, I have actually explained some topics which are like porosity. So in porosity, I have explained you about the definition of porosity and its types, and various formulas, how we have to even calculate. You can even visit my channel to see the numerical problem of what I have explained with the reference of previous gate papers. Okay, and apart from that, I have even explained about saturation, and in saturation, obviously I have explained as same as porosity, the definition, types, and numerical problems with a difference of gate previous exam papers. And if you for today's video, we are going to see about surface tension and interfacial tension. And in this video we are going to discuss about the introductory part, like the definitions we are going to see, then the important terms to understand surface tension and interfacial tension. What are the terms we need to understand before? Then after that we are going to see the formula, what is the formula for surface and interfacial tension, and if possible we will see the derivation of those formulas. Then it will be a homework for you. If you want to do, you can do, or I will even show you in next video the answer for this question. Okay, so let us jump for next slide. Introduction. So as you can see over here, I have an reservoir type of a kind of reservoir model. So in this, if you see, I just wrote two kind of structures, duck nut and a pancake structure. Okay, in later videos I will explain you what are these structures all about, but now let us see the first point. So whenever you see surface tension and interfacial tension, these two terms will comes into picture only if our reservoir is of multi-phase fluid system. Okay, so here if you see, a reservoir is of multi-phase fluid, which is nothing but first one is aquifer, which means water, and the second one is oil, and the third phase of the matter is gas. Okay, so in this reservoir you can talk about surface tension and interfacial tension, right? And another thing is that all these fluids what are present in the reservoir, obviously they are immiscible, but for that surface and interfacial tension, the fluids has to be immiscible to each other. Okay, and the next thing is that due to surface tension and interfacial tension, this oil water contact and this gas oil contact, and if there is a gas reservoir, then at that particular point the gas water contact will come into picture. Okay, so the reason behind these oil water contact, gas oil contact, gas water contact is nothing but surface tension and interfacial tension. And obviously there are some other kind of parameters which are which considered to be the reason behind gas oil contact and oil water contact, but these are considered to be the main reasons. Okay, right, so let us see the next point over here. So it is nothing but the forces at the interface of two immiscible fluids is called the interface or surface tension. They both are classified based on state of matter, right? So this force, what I mean to say, the interface of two immiscible fluid means, as you can see this region, this particular region, where you can consider that this particular phase is of oil and this particular phase is of water. So obviously oil and water are immiscible. So at this particular point, the forces act. The forces means the interfacial tension acts. And apart from that, it is also written that they both are classified based on states of matter. Okay. So as I said you that this interfacial tension and surface tension will act at the place where the two fluids are meeting. So the place where two fluids are meeting, if they are different in states of matter, then based on that we can say that like I wrote the final point over here, if the force acts between gas and liquid, if the force is acting between gas and liquid, like over here I have a gas and the green region is of gas, and the red region, as you can see, this particular point, this particular black point is nothing but your gas oil contact. Okay, so if the force act between gas and oil, then that is considered to be a surface tension. Okay, and if the force is acting between the interface at the interface of two fluids in sense liquid phase, like oil and water, so at this particular point if you consider, then this is nothing but your interfacial tension. Okay, so in next slide if you see that what are the important terms that we have to understand before we go into surface tension and interfacial tension. Like you can see in the diagram that we have two terms which are nothing but cohesive and adhesive force. Okay, so these are like poles, which is nothing but water. These are this particular object is nothing but a charged object or a polar object. As you can see over here, it is written. Okay, so let us see first point. So cohesive force is nothing but the attractive force between like molecules. Like you can see over here, this hand shows you the cohesive force, like H2O combines with H2O. Okay, and the next is adhesive force. Like if you see this particular hand, then H2O is trying to meet with a molecule of other property. Okay, so the clinch, you can say the clinch means the attractive property of a different molecule is nothing but your adhesive force. Okay, so why I am trying to explain you this means, as I have explained you in this slide, that at this particular point there are some molecules which are clinched to each other, but they are not mixed up. So that particular point gives you the adhesive force, and within the same force, if the molecules are attracting towards each other, then that will give you an cohesive force. Okay, so because of that reason, you have to understand adhesive and cohesive force. So what is the use? So when cohesive force of the fluid is stronger than the adhesive force, then the liquid concave down in order to reduce the contact with other fluid. Okay, so what I mean to say over here is, if you have an cohesive force, if he is having a larger force or the higher or it is an upper hand in terms of force or pressure when compared to adhesive force, then you will see, you can imagine that, if let us consider this and test tube. So if cohesive force is shorter than the adhesive force, if cohesive force is stronger than adhesive force, then you will feel a concave down type of structure, lower meniscus, you can see. Okay, then this leads to a shorter transition zone. So if cohesive force is stronger than adhesive force, then that will have a shorter transition zone, and for vice versa, what I mean to say is, if adhesive force is stronger than cohesive force, then you will be having a longer transition zone. Okay, so I hope you understood this. Then after this we'll see the next slide. Like I have explained you in detail, like you can see in this picture, that let us consider this as oil phase, and this as gas phase. So here you can see the molecules. What I mean to say is the total force, the resultant force of this particular molecule is exactly zero. Because if you see, let us consider this particular point over here. Then if you have a molecule over here also, then you can see that this molecule tries to push these molecules over this side. Okay, but due to some other molecule which is present over here, it won't move from its place. But although if you see at the surface that the upper force of this particular molecule is suppressed by the molecule which is present above of other phase. Okay, although it can be suppressed, or it can move along, or it can move upward due to its density or the pressure. Obviously we have the high pressure with non-wetting phase, which is always an oil phase of reservoir. Okay, so at this particular level, if you find any kind of force generated between two fluids, then that is considered to be an interfacial tension. Okay, right. So what the same thing I wrote over here: when more than one immiscible fluid present in the porous medium, a thin film develop at the boundary between two fluid surface. Right. So what I said you, the pressure between two immiscible fluids generates a thin layer over this point. As you can see, a black color line over here between these two phase. So that is considered to be your thin film, or you can consider this particular it is an interfacial, due to interfacial tension. Okay, so let us see the next point. At the interface of the fluid, the force exerted by two immiscible fluid phases is dissimilar, which leads to the phenomena of interfacial tension. That's the same what I have explained you just now. Okay, so let us jump on next slide, which is nothing but your surface tension. Okay, so if two immiscible fluids like air and some other kind of fluid, which may be oil or water, if something force if some force happen near to their contact area, then that also develops a film due to surface tension, where you can consider that the density of air is much lower than the water or the oil. So here you can find the shorter uh, transition zone, or the less height of air gas oil contact. Okay, so the force exerted on the boundary layer between the liquid and vapor phase per unit length. So here you have to consider that whenever you are calculating, whenever you are doing some calculation regarding surface tension, so you have to keep in mind for this per unit length criteria. Okay, so it's as same as the previous phenomena what I have explained you for interfacial tension. It's just case that here instead of oil you have an air. Okay, so, and finally the units for this interfacial tension and the surface tension is dynes per centimeter, and it is denoted by this particular symbol psi. Now let us see at what's the formula for surface tension and interfacial tension. So for gas and water, and for oil and water, the formulas are nothing but, so this is psi to the base GW is equals to R into H, water density into acceleration due to gravity, divided by the contact area, 2 into cos theta, right? And this is the same, as you can see that you have an extra term called extra term of density of water and density of oil. Okay, so these are just the notation what I just wrote over here. Okay, so here radius is represented in terms of centimeter, acceleration is grams per second square, and density is lb per feet cube, or you can consider in terms of other units, and contact angle is nothing but in terms of degrees. Okay, so now let us see the derivation. So here you can see that you have a system in which you have two fluids which are nothing but water and air. So here at this particular point 3, if you see that you have a lower meniscus. Okay, and it is due to like the cohesive force is larger than the adhesive force. So because of that reason you have a lower meniscus. Although it will be same if you even include this kind of this test tube. Okay, so this particular thing is nothing but your test tube. And if you just insert a test tube in the beaker, then you will note increase in height, which what I just represented over here as H. Okay, and this particular zone has a higher uh, lower meniscus. That is nothing but that is due to the higher zone of water and the shorter zone of air. Okay, and if you just exaggerate this particular term, this particular meniscus to an to this level, then you will see an contact angle. Okay, then you will see this contact angle. So this will represent you with another property called wettability, that I will going to show you in next terms, in next videos. Okay, so this phi is nothing but your wettability. Okay, so let us now see the derivation for surface tension and interfacial tension. I hope you understood this figure. Okay, so by taking R as the radius of capillary tube, so here I am just considering this tube, okay, for the derivation. So the total upward force is given by, so here obviously there are only two fluids, so these two fluids are responsible for upward movement along with the test tube after insecting the test tube. Okay, so that you will consider as F force is equals to 2 pi r, which is an area of this test tube, and obviously there will be an surface tension along with an contact angle if you consider this particular area. Okay, so let us see the next point, which is nothing but after seeing the upward movement. So obviously for this upward movement there will be an equal and opposite counteracted weight from upward towards downwards. So what I mean to say over here is the force which is moving upward is counteracted and equivalent of the force at which is moving downward. So that particular area will give you pi r square into H into density of water into density of air into gravity. Okay, so after you see that, let us continue the derivation. So if you consider the density of air, which is quite negligible in the comparison of water, so finally the F down will become as pi r square H. Sorry, I didn't wrote H over here. Okay, rho W into G. Okay, so as I said you that force moving upward and force try to move it downwards, they both are equal, so I'm just equating both the equations. So finally what I got over here is like 2 pi r psi GW cos theta pi r square H into density of water into G. Okay, but I am just rearranging the equation. Psi GW is equals to, I'm just sending everything towards here. Then over here you can see that this R and this R gets cancelled, and this 2 cos theta will be in the denominator, and obviously this pi and this pi will also get cancelled. Okay, so finally you got an equation for gas water system. So that will give you a surface tension. Okay, the only reason because it is surface tension based on states of matter, which is nothing but liquid phase and gas phase. And if you consider similarly if you do for oil and water, which what I mean to say is interfacial tension, then that will give you an psi of OW is equals to RHG into rho W minus rho oil, means density of oil. So why I am considering oil over here is the density of oil is not negligible when it is compared with density of water. So it is as same in the denominator, it is as same as 2 cos theta. Okay, so now you have everything. So let us approach for numerical problems. So here you have a question that you have to do as in homework if you can. Obviously I will show you in next video what is the solution for this particular problem. So 001, so that's an end for today's video. So these are the references what I have used to prepare this presentation. Okay, then apart from that, if you have any kind of query, then you can you can contact me. You can contact me on nawaz.delta.au@gmail.com, and you can follow me on YouTube and Facebook and LinkedIn, and even SlideShare. And even on SlideShare you can find this PPT. Right. So that's an end. Thank you so much for your patience. And if you like this video, then hit like, share, comment and subscribe to my YouTube channel Petroleum Universe, and press the bell icon to receive the latest notification of my videos. That's an end. Stay safe. Thank you. Bye bye.